Suppose the basketball in the previous problem is taken to a depth, deepest part of the ocean and released. At this depth, approximately 11,000 meters, where the water is negative 2.3 degrees Celsius, what would be the volume of the ball? Or what would the volume of the ball be? So the number of moles inside the basketball is going to remain the same. Now I've got some other numbers in terms of the volume of the basketball that aren't listed in this problem that I had in the previous problem. So that's one of the givens that I have. And I also have the fact that it starts on the surface of the water where it's 1 atmosphere and 20 degrees Celsius. So the gas constant will also not change, and the initial conditions to calculate the number of moles, Nr, that's number of moles times R, won't change on the surface as it won't change on 11,000 meters because the ball is sealed. So I'm going to use P equals P naught plus rho GH to find the pressure at that depth, and then I'm going to use the ideal gas law, Pivnert, PV equals nRT, to find the new volume. So here's PV equals nRT. Everything that stays the same, I'll put on one side of the equation. Everything that changes, I'll put on the other side of the equation. So Nr at the surface, number of moles times R, is the same at the surface and at 11,000 meters. So in other words, here, mathematically, this is the statement that I just said. So if this is true, that means that PV over T at the surface is equal to PV over T at 11,000 meters. So now I can plug in all the givens, and remember there are other givens from the previous problem that aren't shown on the top of this screen. But I can put in my givens. The problem is I don't know the pressure at 11 meters when I put them in, at 11,000 meters. So I'll use P equals the atmospheric pressure plus rho GH in this case. Put in my numbers, and I get 1.079 times 10 to the 8th pascals. So now I can put in my numbers. I've got the pressure at the surface of 100,000 pascals. I got the volume of the basketball that was given in the previous problem of 0.00747 meters cubed. I'm at 20 degrees Celsius, so that's 293.15 Kelvin. On the other side, I've got the pressure I just calculated at 11,000 meters, and I know the temperature of it, how much colder that's going to be on the other side. So now I can isolate for V at 11,000 meters, and I get the really, really small volume of my basketball.